Hello class, this is a video tutorial on quadratic functions, part 2 of the discriminant. So as we know, we have a quadratic function, f of x equals ax squared plus bx plus c. From this, using the properties of the discriminant, in case you've forgotten it, it's delta equals b squared minus 4ac. If we know that the discriminant delta is less than 0, we have no real roots. If we have equal to 0, it has one root, and greater than 0, it has two real roots. And if you don't fully comprehend what that means, you should take a look at the previous video I had on this. So once we know, because we know these properties, we can determine unknown values of a, b, or c to have the exact root properties that we want. So let's get straight into some examples here. So given f of x equals px squared plus 12x plus c, notice how we don't know what the value of a is. Calculate the values of p so that f of x has exactly one root. Well, we know that one root means delta equals 0. So let's write that information down. And so it's what this question is saying is, what values of p can we put in that will give us delta equals 0? Well, it's hard to guess and check this, so why don't we just find what delta is first. Just let me copy it out here just so you're familiar. We know that delta is b squared minus 4ac. So let's put these values in. A is equal to p. B is 12 from our quadratic function here, and c is equal to 6. So let's substitute all these values in. B is equal to 12, so 12 squared is 144, minus 4 times a, which is p, and c is 6. Evaluating all of this, we get 144 minus 4 times 6 is 24p. And we said, well, from the question, we want to let delta is equal to 0. So we take this expression and we let it equal 0. Let me start a new sub question into here. 144 minus 24p is equal to 0. Well, now it's just a matter of solving for p. So moving 24 to the other side and dividing by negative 24. So this will give us negative 144 over negative 24. Whatever this might be on the calculator, let's take a look. This will give us 6. P is equal to 6. There's our answer. And just so we can fully comprehend, what this means is if we substitute our p back into 6 for the function of 6x squared plus 12x plus 6, this function will have one root. I don't know where it is, I just know it has exactly one root. So let's get into more examples here. Given g of x equals 4x squared plus qx plus 16, calculate the values of q so that this function has exactly two roots. Well, I hope you can remember what two roots means. Two roots means delta is greater than 0. So let's write that information down. And, well, we need to know what delta is. So let's find an expression for delta. For this, we need our values of a equaling 4, b is equal to q, and c is equal to 16. So this will give us delta equals b squared minus 4ac. Substituting all the relevant information into the formula, this will give us q squared minus 4 times A, which is 4, times C, which is 16. Gonna need some, what's it called? Gonna need some calculating here. So negative 4 times 16. Negative 256. This will give us Q squared minus 256. And now, from the beginning of the question, we need the property of two roots. So we're going to let delta be greater than 0. So we're going to let this be greater than 0. So this is the new question that we need to solve. So Q squared minus 256 is greater than 0. Adding 256 to both sides, so Q squared is greater than 256. Just so you understand what I did, I added 256 to both sides, like so. And now I'm going to solve for Q. Q, the positive or minus, is greater than the square root of 256. I'm not aware of what that is. 16. So Q is greater than 16. But now take note, we have two different values for Q, positive and minus. So let's take the positive Q is greater than 16, and the negative Q is greater than 16. Or, more specifically, let's divide by negative 1 on both sides. Q is less than negative 16. So, as a number line now, this will look like the following. We have negative 16 here, and we want Q to be less than that. And we have positive 16 here, and we want Q to be greater than that. So this, in bracket notation, is going to be Q negative infinity to negative 16, non-inclusive, union with positive 16 to positive infinity. Let me make that a little bit neater, like so. So that is our answer for part 2. Let's do one more question here. Given h of x equals 2x squared minus 8x plus r, calculate the values of r so that g of x has exactly 2 roots. Oh wait, sorry, hang on. No, actually, I thought I was going to make this no roots, but I'm going to let you try and figure that yourself later. But let's do this question. We want it to have exactly 2 roots. So once again, we want to let delta greater than 0. So just so we remember, delta is equal to b squared minus 4ac. And we need to know the values of a, b, and c. So a is 2, b is negative 8, c is equal to r. Substituting these values into our equation, b squared is negative 8 squared, negative 8 squared, minus 4 times 2 times r. This will give me 64 minus 8r. And we said we want to let this be greater than 0. So we're going to let this be greater than 0. So the new question we need to solve is solving for r greater than 0. Subtracting negative 64 on both sides. This will give us negative 8r is greater than negative 64. Dividing both sides by 8r, we get r is less than positive 8. And just so we can visualize this a little bit more, here's our number line. Here is 8. So it's a number line for r. and we want r to be less than 8, so all these values below it. So in a bracket notation, this would be negative infinity to 8, non-inclusive. So I hope that gave you an insight into the discriminant and further uses that we might have for the discriminant in quadratic functions. Hope to see you in the next video. Best of luck.